Okay, so in this example up here, I want us to find the equation of the tangent line when x is 2. I'm going to go and change that to when. When x is 2, for f of x equals 6 minus x squared. Okay, so f of x is 6 minus x squared and x is 2. So what is the first thing we need? We're writing the equation of a tangent line. We need the derivative, right? So we're going to do this without our calculator first, and then I'll show you how to use your calculator to check it. Okay? Our derivative of 6 minus x squared. Josh, what's our derivative? 2x? Negative 2x. Agree, disagree? Agreed. I like that we added that negative in. Okay, so now what do we need to do with the derivative? Plug what in? So our slope is what? Negative 4. If it helps, like if you're writing the tangent line equation, if you need to write the word slope next to that number, feel free. Okay, you need to recognize that the derivative means slope. Okay, now let's use our calculator to check that. Are you ready? This is going to be awesome. I didn't open my calculator. Hold on. Okay. Everyone go with me to math. Math is under alpha. Do you see here 8? It says n deriv. Okay? This is your derivative button. Your calculator cannot find the derivative, but it can evaluate the derivative at a point. So we're going to go to math 8. Now, TI-84s, some of yours will look like this, some of yours will look different. So if yours looks like mine, please follow along with me. We need to type in our function 6 minus x squared, and then comma, you have to tell it which variable you're taking the derivative with respect to, and then you have to write another comma and say what value you want to evaluate that derivative at. If you are a TI-84, you get this. You get this, right? So you're going to type an X here, which will put an X right there. You'll type in 6 minus x squared, and then here you'll put a 2 to evaluate it at. You should get a slope of negative 4. Any issues? Oh, don't. Everyone can get that okay? All right, let's finish our problem and then we'll practice it again. Now, if we want to write the equation of a tangent line, what else do we need? Careful. We need something from the original equation. Logan says plug in negative 4 to the original equation. Agree, disagree? What do you think? the y value when x equals 2. Logan, how do you feel about that? Good? Okay. -4 is our slope. That's all we need it for. Our x value is 2, so we need our y value. Okay? So when we plug in 2 to our function, what do we get? 2. So our y value is 2. Okay? So Abram, how do we write the equation of the tangent line? Here's our coordinate, right? And here's our slope. So how do we write it?
Y minus 2 or -4 and then x.
Good. You're going to have to do this tomorrow on your quiz. I'll give you a function. I'll give you maybe an x value. Maybe I'll give you an xy value. Okay? But you need to know to find the derivative, to find your slope, and then write the equation of the tangent line. Okay. All right. I'm going to bring back something that you have talked about before. Okay? Besides slope of the tangent line, what is our other synonym for derivative?
Instantaneous rate of change.
Instantaneous rate of change. Okay? Last year in pre-calc, you barely touched on something called average rate of change. We need to understand the difference. Okay? Average rate of change is the slope between 2 points on a graph versus, I'll come right back, the instantaneous rate of change is just the slope of through 1 point on your graph. Okay. Average rate of change is the slope between 2 points on your graph versus instantaneous rate of change is just the slope of that tangent line hitting 1 point. Average rate of change is going to be the slope over an interval, okay, where instantaneous rate of change is just at a point. Okay. Average rate of change, slope between 2 points. Instantaneous rate of change is the slope at 1 point. So both average rate of change and instantaneous rate of change should trigger slope for you. Okay. The difference is average rate of change, we're going to need 2 points on our curve to find it. Okay, versus instantaneous rate of change, we just need the derivative at that point. Okay. So here's our example. 6 minus x squared is still our function. Okay, kept it the same just for simplicity. I want to find the average rate of change over our interval 2, 5. Okay. Average rate of change means we need to find what? Say it. I heard it. Say it louder. Slope. Okay. Anytime rate of change is in there, you should think of slope. So average rate of change, slope between 2 points. We're going from x is 2 to x is 5. What should we probably know about x is 2 and x is 5? Their y values. What do we get when we plug in 2? What do we get when we plug in 5? What? Negative 19. Can anybody confirm or deny Cole's? Okay. So our average rate of change means we're just going to find the slope between 2 and 5. y2 minus y1 over x2 minus x1. So we get what? Negative 21 over 3. Our average rate of change, we're dropping 7 y's per 1x. That's our average rate of change. Versus instantaneous rate of change. Instantaneous rate of change means we need to find the, everyone together? Derivative. Okay, we already determined that our derivative was negative 2x for this function. So all we have to do is plug in negative 2. Our instantaneous rate of change at negative 2 is 4. How many of you are in or have had, I don't even know what I'm asking, physics? Okay, that's a little bit of physics for you. We're going to talk about falling objects, not throwing an object, just dropping an object, okay? Falling objects. Okay? The position of a free-falling object is given by this. Its velocity is given by this. Go ahead and write it down, and then we're going to talk about the relationship of the two equations. This should look familiar to you because it's something that you at least did potentially in algebra 2. Whether you remember that or not. Okay. Here is where some of you may get annoyed. In physics, what's your gravity constant? Meters per second squared, right? Okay, we aren't always going to work with meters in seconds. Sometimes we will work in feet in seconds. I know that could bother you, some of you who are like really into physics. I'm sorry, but that's just how it works in math. Sometimes we'll do meters, sometimes we will do feet, which is why I did not put the gravity constant in there. If we're working with meters in seconds, we put 9.8. If we're using feet in seconds, then it's negative 32 feet per second squared. Okay. Okay, so 20-second conversation with your pod. What's the relationship between the position and the velocity function? 1, 2, 3, go. And why does it not know? Right, so velocity is going to be the number.
now look at this.
So t's are variable. T is like an x. Okay, Isaac said velocity kind of looks like it could be the derivative of position, but he's a little unsure. What do you think about that?
But I didn't realize that.
Well, I'll tell you what, we are talking about derivatives.
Oh, that's true.
GX.
Okay, both g and initial velocity are going to be numbers, right? We're going to plug in a number for gravity. We're going to plug in a number for initial velocity. We're going to plug in a number for initial position. Those are what all of those mean, right? So these are going to be numbers. So if we look from position to velocity, if we take the derivative here, we multiply the 1/2 times 2, decrease our power, right? Our power is 1, so we get that number. Okay, so really, if you know the position function, you don't even have to know what this is because you can take the derivative to find it. Okay, so what we do need to remember is that a free-falling object has this right here because then this is just the derivative. Okay, so my fault for not talking about these letters before. G is gravity, we'll put a number in there. V naught is initial velocity, we'll put a number in there. S naught is initial position, S is for position, kind of an awkward variable for that, but that's just how it goes. We'll put a number in for there. Okay. So, a physics book somehow is dropped from the top of a 220-foot building with initial, well, I guess it's thrown straight down with an initial velocity of 26 feet per second. Okay? How many of you have wanted to just throw the physics book off the top of the building? No? No one? Good. Good. That makes me happy. Not yet, at least. Larry, you're smirking back there. You've wanted to? Okay, you probably don't want to. Yeah, you probably don't want to do that. Okay, if we're talking about feet per second, then our gravitational constant is negative 32 feet per second squared. So let's write the equation of our position. 1/2 times g times t squared would be negative 16 t squared, right? 1/2 times g times t squared, 1/2 times negative 32 times t squared. Plus our initial velocity is 26. However, what direction are we throwing the book? Okay, so that velocity is negative velocity because we're going down. Plus, what's our initial height?
220.
220. So that is your position. If we wanted the velocity equation, what are we going to do?
You need to take the derivative.
We need to take the derivative. Okay, so Michael, help me out with the derivative. What? Yeah, just help me out. Like, what's the derivative of negative 16t squared? Good. The derivative of negative 26t? And the derivative of 220? Perfect. There's our velocity equation. Okay? From here, it's just a matter of plugging in numbers to the right place. Okay? We've done the hard part. If I ask you, how long does it take the book to reach the ground? How long? We're looking for time, so we're going to solve for t. ground means what? Okay, let's not use y. We have position and we have velocity up here. So the ground is when what is 0? Position. All right. So if we set our position equal to 0, okay, how are we gonna have to solve that? We can use a quadratic formula for sure, or we can try to factor. Whichever you prefer. I don't think this one factors. Sometimes they do, sometimes they don't. So go ahead and get out your calculators and help me out with the quadratic formula. You're going to get two answers. One's going to be negative, one's going to be positive. Which one are we going to want?
Positive.
We're going to want the positive one. You are dividing by a negative number. So do you want 26 plus something or 26 minus something? Because we're going to be dividing by a negative number. Jessica, you have something? 2.98. Give me 3 decimal places. 4. This is what Josie got. Anyone else getting there? You got the negative one?
No.
You got the plus one? I think it was the negative one, like negative 4 point something. Okay. All right, so how about this? What will the velocity be when it reaches the ground? What does that mean? What are we looking for? We're looking for velocity. So, what are we plugging in for t? 2.984. When it hits the ground, it's 2.984 seconds. So what the velocity is there means we need to plug that number in. Okay. Now, some of you, I'll remind you of some things about your calculator. When you did the quadratic formula, you did 26 minus the square root squared. Okay. Oh, I did something wrong. Gosh darn it. Oh, shoot. Right, divided by negative 32, right? Okay. So when you get that answer, instead of having to plug it in again, you can say negative 32 times second answer minus 26 and get, we have a velocity of negative 121.474 or 474. Should the velocity be negative? Yes, because our book is falling down, so our velocity should be negative. Okay? Questions about the position and velocity? Okay, it's really a matter of reading the words and figuring out what you're plugging in and what you're solving for. Okay? On tomorrow's quiz, okay, I will ask you one question about the limit definition of the derivative. You will have to do that once, okay? And then you'll have to do it on the test. And then other than that, you'll just have to recognize, okay? You're going to have to apply the power rule and cosine and sine rules, okay? You're going to have to do some rewriting to take the derivative, okay? I'm going to ask you to write the equation of a tangent line. I'm going to ask you to find points of horizontal tangency. That's something you'll practice in tonight's homework, okay? I will ask you to find average versus instantaneous rate of change. That's something you'll practice tonight. I will ask some questions about the relationship between a derivative graph and a function graph, okay, kind of like we did in that first section. And then there will be one question which involves the falling objects, okay. I will give you the equation for the falling object on your quiz, so you won't have to worry about remembering that. But it is important that you understand that the velocity is the derivative. You should not need a calculator on the quiz, okay? But what I want you to do in your homework tonight is anytime you evaluate a derivative at a point, practice using your calculator, not only to check yourself, but to practice using your calculator, because your calculator skills will become more important later, but we need to practice them now. So, on your gold sheets, here's your homework. I'm going to go ahead and upload all of the solutions to the homework to my website. I don't have like a review worksheet for you for the quiz, but tonight's homework I'll put the solutions to online. That way you can at least check your work for the even problems before the quiz tomorrow. I may take like 5 minutes worth of questions tomorrow, but that would be about